Hi everybody. In this video I'm going to talk about how to find the slope of a line. There are two methods in particular that I'm going to show you. One is by counting and the other is by using a calculation. So let's go ahead and write and begin. In this example you can see that this graph has two clearly marked points, and the first thing I want to do is, if I want to do the counting method, which I'm going to do over here, so counting method. If I want to do this method, then I need to start by identifying both points with a capital letter. Now this is something kind of stylistic for me personally. I like doing it this way. It's not necessarily the only way to do it. There are two ways to count. Either you decide you want to go from A to B, or you want to go from B to A. Now it doesn't matter in the end, and you're going to see why in just a moment. But let's go ahead and begin. Let's go from A to B, okay? So if we were to go from A to B, I need to first move down, and in doing that I need to track my movement. So it's going to be 1, 2, 3, 4, and I stop there because this is the level at which point B sits, as you can see over there. So because I went down 4, this is a negative direction. I should have probably mentioned that in the beginning, that when you move along the coordinate plane, if you're going up, you're going in the positive direction. If you're going down, negative direction. And if you're going right, positive direction. And if you're going left, negative direction. So as a rule of thumb, this is the way this goes. And so this guides my, my numbers. Okay, so moving on. So I have a -4, and I'm going to go ahead and move to the right from this point. So I'm going to count my squares going to the right. It's 1, 2, 3, 4, 5. And because I moved to the right 5 times, what that means is my 5 is a positive value. To write the slope, I have to represent slope as a change in my direction, a change in my location or position of my y's versus a change in my position on the x-axis or the x-axis, so right and left movement. So it's a change in your right and left direction compared to a change, oh, pardon me, this is, should be up and down. So a change in your vertical direction versus a change in your horizontal direction, okay? And so when I write the slope for going from A to B, my slope will be, it'll be -4 because I went down 4, and it'll be over +5 because I went to the right 5 times. Now these are a set of directions to go from point A to point B. Now let's look at what happens when you go from point B to point A. I'm going to change my color over here, and let's go with purple. So if I were to go from point B to point A, then I start at point B and I track my movements. Now I'm going to have to go up this time. So 1, 2, 3, 4. This time, because I went up 4 times, this is a +4. And then I have to move from here left. So 1, 2, 3, 4, 5. Now because I had to go left this time, it's a -5. So when I write the slope again will be a change in my vertical movement versus a change in my horizontal movement. So this is going to be a +4 over a -5. Okay, now let's analyze this a bit. This means going up, this means going left. Let's analyze these two things for a second. -4 over 5 and 4 over -5 actually mean the very same thing. They mean the same thing. There is no difference other than just where the negative is, but because a fraction is, it's a combination of two numbers tied together, the negative doesn't make a difference where the negative is, whether it's in the numerator or denominator. It is still a negative value. If you were to divide 4 by 5, what you would get is 0.8, right? So if I were to divide this, what I would get over here would be 0.8. And because I divided negative by positive, this would be negative 0.8. Well, the same thing happens if I were to divide 4 by negative 5. 4 divided by 5 is still 0.8. And a positive divided by a negative is still a negative. So you can see that in terms of decimal values over here, when we're looking at decimal values, this one and this one come out to exactly the same thing. Okay, and so for that reason, it doesn't matter where the negative is when you're comparing values. The only difference that the location of the negative makes is when you're thinking about the direction you take. And this is why I wanted to do a comparison of going from A to B versus B to A. Because if you're looking at the negative up here, that means that your first movement must be to go down. Versus if you have a negative down here, that means that your second movement is going to involve going left. Okay, so this is the counting method to get the slope of a line. The second method I want to show you is how to get the same values, but instead of counting, using a calculation. Now, this does go back to the whole idea of representing slope as a change in your direction. Now, the word change always has to do with subtraction. Okay, where you're subtracting one number from another. Think of it as you go to the market or store, you pick up an item that is $1. You have only a $5 bill, so you pay that, and what you get in change is $4. And the way that's calculated is what you gave subtracted from the value of the item comes out to what you get in return as your change. So it does involve subtraction. That is the nature of change. And so you want to show by how much something has changed from one thing to another. So we're going to use this concept to actually calculate slope, and it goes something like this. I'm going to create a division right here. To show the change, you have to first begin with the change in your y's. So the change in your y's involves taking your first y value or your second y value and subtracting it from the other one. Okay, the way you do this is really, it's up to you personally, but some people like to put the second one minus the first one. The first one minus the second one is just as good. You have to make sure though that when you do the changes of your x values, that you represent it in exactly the same way as you did with the y's. So if you're going to subtract the first one minus the second for the y's, you must also do the same for your x's. So it's going to be the first x value minus the second x value. Okay, like that. So what we need to do is first identify the location of our points A and B so that we can get the exact coordinates from their ordered pairs. So I'm going to erase all this and go back to our graph over here, and let's go ahead and place that. So this is minus. So if I were to go back to our points over here, point A is at -1, 0, and point B is at, this looks like 4, -4, 4. So it doesn't matter which you call your first point or which you call your second point, just like it didn't matter if we went from A to B or B to A. Just pick one, okay? So whichever one you decide to go with, A to B. If you go from A to B, that means that point A represents your first x and your first y. If you go from B to A, that means that your point B values, your 4, -4, represent your first x and your first y. So it's just personal preference. I'm going to go ahead and say that I want my point A to be my first x and my first y, which means that automatically my point B becomes my second x and my second y. So let's go ahead and return to the formula, and plug in our values. So what we have is this. We have slope is equal to, this is going to be 0 minus my second y value, which is -4. So it's going to be my 0 changed into a -4, okay? Or 0 minus -4, however you want to think about that. 0 changed into a -4 when I went from point A to point B. And likewise in the denominator, when we're talking about the x's, the first x is -1, right? For point A. Well, -1 eventually changed into a 4. So it's -1 minus 4, okay? And so we go ahead and simplify this, and then we're done. So as you know, these two become a positive. So then what I have is 0 plus 4, which is 4. And then in my denominator, -1 minus 4 is -5. And this is my slope. Just to be clear, this once again corresponds to the following. So this 4 means that I had gone, I could go up 4 times, and then this -5 means I would have to then go left 5 times. So after I go up 4 times, I would then have to go left 5 times. So this is a scenario where I'm going from point B to point A, because as we saw, which was right over here, we got the same scenario when we went from point B to point A using the counting method, right? We got 4 over -5, which is like saying -0.8. Well, I got the same thing, but rather than counting squares, I simply grabbed the 2 x coordinates, the 2 y coordinates, and I represented the change, how they changed. So how the y's changed from one to another and how the x's changed from one to another. And what I got in the end was exactly the same thing as I got by counting. And that's the beauty of using the calculation method, because if you have really big numbers, like for example, -324, 467, and then you want to go from there to point B, and that one is at 21, -2. Well, you're going to have a heck of a lot of squares that you need to count, and no one's going to want to do that. So there has to be a more efficient, quicker way, and fortunately there is. It's simply knowing that change represents a subtraction of 2 values, and therefore you show by how much one thing turned into another. And which ties directly into the counting method, by the way, if you really think about that. So with that said, I hope that this video did help you a little bit, at least, understand better how to both get the slope through counting and using the calculation method. Please stop by, leave a comment. I always like to know how I can improve my videos. And as always, thanks for watching. Bye-bye.